So, hello everyone. My name is Sarah, and I'm electrical engineer, and I am lecturing in ATU Donegal campus in the Department of Electronics and Mechanical Engineering. And I'm very honored to be the part of this module that is basically power system dynamics and control. So today I'll just give you a brief introduction, overview, course content, details of this module. So basically, in this module, uh, the learner introduced to the dynamic behavior and the control mechanism essential for the power system networks, and dynamic behavior as well as the control strategies can be implemented in various operational conditions. That could be your normal conditions, or that can be your faulty conditions. The interesting thing about this module is the content has a flavor of different fields. For example, it have some knowledge about the electrical engineering, then control system, applied mathematics, sustainable energy management. Uh, in this module, we'll encourage the students to explore advanced control techniques technically and ethically implementation in the power system, considering their broader impact on grid stability, reliability, and renewable energy integration. So, next is the about course contents in this particular modules. Initially, we will definitely go for the introduction, and then we'll go into the structure and the components of the power systems and overview of the dynamics like stability, reliability, and control challenges of your power system and the grid also. It also includes its importance with the microgrid as well. Uh, then definitely we'll go and examine the principles of synchronous machines, their dynamics. Then another very important fundamental electrical machine, that is your transformer. Then we will look for the transformer control mechanisms. And definitely we will also look for the power electronics as well. Then we will move on towards the designing and the implementation, and we will go and design the control strategies, including the control systems for the high voltage systems, for example, flexible AC transmission systems, voltage source converters, and we will go for the control and the design techniques of distributed energy resource controls, for example, MPPT control for your solar panels, and then any control mechanisms for your wind turbines. Then later on, understanding the dynamics of the renewable resources. And that's very important part because we know that Ireland has a great potential of the renewable energy, but when we integrate the renewable energy sources with our conventional grid, then there is a very big question for the stability. So in this content, we will cover how we can integrate our renewable energy sources, how we can control them, and how we can make sure the stability of our sorry of our power grid system. So this is very important and part of this content. I will go toward the course schedule, then 12 online lectures along with the weekly assessments, and lecture will be conducted every Wednesday at between 7 to 9 a.m. 9 p.m. And then we have 3 hours lab sessions that will be delivered on Saturday at ATU Donegal. If we talk about the module assessment, then 50% coursework, and knowledge-based assessment is also 50% in knowledge-based assessment. We might we go for the submissions of the reports or assignments, and it will include two assignments, each carry 25 percentage. If we talk about the level, then it's intermediate to advanced level of the module. In ETU, we do have some academic support, okay, and that academic support will be in the form of different facilities. One of the facility is the curve that exists in lifelong learning. This facility is basically uh, involve the groups of the students. Those are mature students, the students with some physical and learning disabilities, or the students from the low income families. So, and the students who they need some additional support in relation to the communication. So, those all students will be taken care by the curve. And then we do have some communication learning center. This is also under the curve, and they deal with the students who have some issues with the communication. Then we have virtual learning environment, then computer services, and then students with the physical or learning disability that also under the umbrella of the curve. If we talk about the outcomes after finishing these modules, then we after this modules, the students will be able to have a strong foundation in power system operations, stability, and transient dynamics, along with conditions that can be normal or that can be abnormal. If we I say abnormal, that it means that it can be faulty condition, it can be transient condition, any kind of the condition. Uh, this module helps students to analyze the real world disturbances, for example, voltage fluctuations, frequency deviations, and the blackouts. And after the completion of this module, our students were able to design and implement the control mechanisms to enhance the grid stability and reliability. As I discussed before, that Ireland has a great potential for the renewable energy resources. And according to the statistic, in 2018, wind turbines generated 28.1% of the island's electrical demand. That increases to 36.3% in 2022. So this module will also help the students to handle the challenges of the stability and control when they are integrating the renewable energy sources with the conventional grid. And this module also helps students to modernize their grade systems. It also includes hands-on simulation using the industrial standard software. One of the very extensive software that is the MATLAB, and the second software that is the Electrical Transient Analyzer Program. The short form is the ETAB. The both software are very extensive softwares, especially in the fields of the grid system, in the field of the power systems. And if we talk about the career opportunities, so after the completion of this module, we have large career opportunities, especially in energy sectors. So the students can go into the grid automation, smart energy farms, renewable energy companies, power utilizers, and transmission system operators. So it has a wide application. The students will be uh, adjust themselves in anywhere of the energy sector. So this is all about this module. If you have any question, I'm very happy to answer them.
Thanks, Sarah. That was really comprehensive. Stefan, you got a private overview. Would you like to ask any questions?
No, fairly clear. Suppose just relating it maybe to our own facility, we be covering sort of power quality and things like that, and getting a better understanding of power factor and things like that.
Yeah. Power factor improvement is a different side, but definitely we will go and look into this as well. Mainly, we look for power systems, stability, reliability, the dynamics we are facing in our power system or the grid systems, and the transient behavior that is very important. Any sudden changes if we have in our grid systems, in our power system, then how we can tackle, and the control strategies are very important for that. We'll go into the electric machines. We'll go and design the electric machines control systems. For example, synchronous machines. That is a very important and vital machine of our power systems. Transformers, and definitely we'll look into the power electronics that is basically integrated with our machines. And definitely we will look for the power factor improvement as well, because that is basically the sub part of our whole module.
Perfect. Thank you very much.
Okay. Sarah, thank you. Stefan, thank you for joining us. I'll just stop recording now.